Okay, geometry students, this is 5-1 perpendicular and angle bisectors. Today we are going to prove the perpendicular bisector theorem, the angle bisector theorem, and their converses. And we will use those theorems to solve problems. So make sure that you put in the words perpendicular and angle into your notes. Our vocabulary for today is the perpendicular bisector, in Spanish, mediatriz, and angle bisector, bisectriz. And here we have example 1, and I'm going to open up the Savvis demonstration for this, and you're going to get a compass to figure this problem out. The question is asking, how can you find points that are equidistant from the endpoints A, B? And then what do you notice about these points and their relationships? So here we're in Savvis, and it's the same problem. I'm going to click on the solutions for us to read. You don't need to put this in your notes, but it's showing that step 1, a point that is the same distance from 2 points is equidistant from the points. So use a compass to draw intersecting pairs of arcs centered at A and B. And we did this in chapter 1 when we did constructions. So you're going to take your compass and you're going to open it up a little bit past halfway. And you're going to draw arcs. And you can try changing the length of your compass to draw different arcs. Okay, and so if your compass is less than halfway, it's not going to work. Okay, so it has to be greater than half. You draw your arc, and then you put it at point B, you draw the same arc, and they intersect. The points where the arcs intersect are equidistant, and all 4 of these points appear to be collinear. So we can draw a line through them. And that's what we are noticing the relationship is between the points, is we can draw a line through them because they're all in the same line. And what that tells us is that the line where all the points intersect is perpendicular to the line AB. And it's a bisector, it cuts the line in half. So points that are equidistant from A and B fall on the perpendicular bisector. All right, let's do example 2 in your notes, which we also have a demonstration for. Prove the perpendicular bisector theorem. And you have this diagram in your notes. It says, given that L is the perpendicular bisector of XY, prove that PX is equal to PY. So this side and this side are equal. All right. The first thing that we want to show is that angle XQP, so X to Q to P, is congruent to YQP. Well, why can we say that? Why are these 2 angles here at Q, XQP and YQP, why are those congruent? You should know. So think about it for a second, and then I'll click. All right angles are congruent. Yeah, so they're both right angles, so a right angle is congruent. Now we want to prove that PQ is congruent to PQ, and it seems obvious, right? They're the same line. and that is the reflexive property. So go ahead and add these little bubbles, quotation bubbles, to your picture, along with the markings for the 90 degrees and the two little tick marks to show that they are congruent. Oops. XQ is congruent to YQ. So this piece, XQ and YQ, why are those congruent? Well, we're told that this is the perpendicular bisector, so let's see what they say. Right, so since it's the perpendicular bisector, Q is the midpoint of XY, and XQ is congruent to YQ. I would just say because line L is the perpendicular bisector of XY. PX is equal to PY, and that's what we're trying to prove. And so why is that true? And it looks to me like this is an isosceles triangle. So it says by side angle side. All right, let's look at that. Oh, yeah, we have side angle side. Side angle side. The green is a side, the red is an angle, and the blue is a side. So therefore, if those two triangles are congruent, then these sides have to be congruent as well by CPCTC. So I'm going to give you some time to write down these little thought bubbles and the final proof. So this is a different way to write a proof because it's not a two-column proof like we've done before, but it's still a proof. This is example 3 in your notes. It's asking us to use a perpendicular bisector, and we're going to want our compass and straight edge for this. Mr. Lee wants to park his ice cream cart on Main Street so that he is equidistant from the entrances of the amusement park and the zoo. Where should Mr. Lee park? How can he determine where to park? All right, so here is the zoo entrance and here is the park entrance. So I would want to know where the perpendicular bisector is of this, because if we found that, we could find out points that are equidistant from each park entrance, right? And this could be used for other things like in agriculture when you're talking about different gates that animals are in. This could be used for sports like basketball and where people should be in terms of shooting a basket and throwing the ball. Maybe you want to be equidistant from both players who might have the ball. Things like that. So what is the solution? How do we do this? That is overwhelming. Okay. Step 1, label the entrances of the amusement park. So we don't need to write all of these words. I just want you to label the entrances of the amusement park and the zoo as A for the amusement park and Z for the zoo. And we're going to put dots there and we're going to draw a straight line. Then we're going to take our compass and we're going to draw a perpendicular bisector. You don't need 4 different points. You just need 2 points to be able to draw it. So open your compass to a little bit more than half the length. Draw an arc. Move your point. Well, you can draw the arc above the line and below the line from Z. Then put your compass, don't change the setting. Put your compass at A, open it a little bit more than halfway, and draw your arc. I'm sorry, you don't change the compass. So if it was open halfway, you just move it to A and use that same setting. Where the lines cross or intersect, you put a point, and you draw the perpendicular bisector. Then you notice, where does that perpendicular bisector cross the street, right? Where does it intersect with Main Street? And it intersects right here. So that is where you are going to put, or Mr. Lee is going to put his ice cream cart. Okay, so take a moment to use your compass. Don't just guesstimate and draw these lines. I want you to use your compass and actually find it. So I'll be walking around to make sure that you get this. So now we're going to look at example 4. What is the value of A to D? Well, what we can say is that if this is perpendicular, the perpendicular bisector, so if AC is the perpendicular bisector of BD, which it is, right? Because we have a right angle and we have these two 11s are equal. If that's true, then we have side angle side. So that means that by corresponding parts of congruent triangles, that this side AB, which is 6x minus 10, is equal to the side AD, 3x plus 2. If we write these two equations equal to each other and solve for x, then we know what x is. We can plug it back in and figure out what AD is. All right, so let me show you that in Savas. By definition, AC is the perpendicular bisector of BD, which is what I just said. Then AB and AD are equal by the perpendicular bisector theorem. So we can write that AB is equal to AD. If that's true, then we can write that 6x minus 10 is equal to 3x plus 2. If we solve that by adding 10 to the other side and minusing 3x from this side, we get 3x equals 12. We divide by 3 and we get x equals 4. And like I said, we're going to take that x, we're going to plug it in to this x over here. So we get 3 times 4 plus 2 is 14. So that means that both AB and AD are 14 because they're equal. We wouldn't even have to plug in 4, but if you do, 6 times 4 is 24. 24 take away 10 is 14. So I want you to try that. I know it's a little bit of algebra, but we're here to help you. So do the try it problem after you've written down this part.